Hello guys. So today we are going to study a new problem which is named as twosome on LeetCode or on GFG. So this will be our flow to solve this problem and learn what concepts is it uses to solve it. So our first we will discuss about the its problem statement. So what its statement mainly defines and what is asked in this question, its output, its input category and all. Then we will see the naive or the brute force approach to solve this problem, and then we will look for a better approach. Okay, so as I said, let's move to our first point, its problem statement. So this is a very good question, and it falls in easy category, and on LeetCode or on GFG you can find this question as twosome itself. The name will be same, twosome. So let's discuss its problem statement first. So we will be given two things. First is the array containing n elements, and the second will be a variable k which indicates sum. Okay, this will be our input. Then we will discuss about its output a little bit later. Let's first focus on the input portion only. So first thing which will be given is the array, and the second thing which will be given is the variable k, and it contains a value, integer value, which represents a sum. And what sum? It represents the sum of two elements of this array, x and y. Maybe there exist two elements x comma y which is present in this array and whose sum is equal to this value k. And this is the problem statement. This is the problem which statement, and it is asking us to find this values x and y. And now we will discuss about its output. So there can be two types of output. This problem can be further divided into two categories. First, where you will be asked to return simply a boolean value, true or false, and the second, you will be asked to return a pair of indexes. Okay, we will represent it as I1 and I2. This is the index of x and this is the index of y. Okay, if the first we will discuss the first category where you have to return the boolean value. So in this type of problem, if there exists two variables or two values x comma y in the array whose sum is equal to the value k which is given in our input, then we have to return true, else we have to return false. And here, if there exist two values x comma y inside the array whose sum is equal to k, then we have to return the pair of indexes I1 comma I2, or if they are not present, then we have to return simply -1 comma -1. Okay, so how we can find, or the best way I can tell you that according to my experience, if our array which we have been given in the input is sorted, then most of the time it will ask you to return the boolean answer. Okay, if it is not sorted, then it will ask us to return the indexes, and I will tell you why. It's not like we can't find the indexes in the sorted array and we can't return boolean value in the non-sorted array. We can find both the things in both the arrays, but mostly when the array is sorted, they will ask you a boolean value, and when the array is not sorted, then they will ask you to return the index of the array. Okay, this is what they are asking. This category question will be termed as an easy. This is an easy problem, but this can be easy for someone and medium for someone else. Okay, I will tell you why. When we'll start discussing these solutions, then we will find why this is considered as easy, and this problem may be considered as easy or medium for someone and someone not. Okay, so first of all, we will discuss this category. Okay, our array is sorted, and we have to return a boolean value. So let's write our problem statement once again. So our problem statement says that we will be given an array, suppose its name is ARR, and it is sorted. So let's consider some value 1, 2, 3, 7, 9, and 10. Okay, its size is 1, 2, 3, 4, 5, 6. Am I right? Yes, 6. And we are given the value of k as, let's say, 10. Okay, we are given it as 10. Okay, we have to find this. Then what else have to yeah, we have to return the output as true or false. Okay, so this will be the first problem statement. Our array is sorted, and we have to return a boolean. So this is our first category problem, this easy problem. Okay, so let's discuss its brute force approach, the most basic approach which we can use to solve this problem without considering the time complexity or the space complexity issue. So we are given an array 1, 2, 3, 7, 9, and 10. We have to find two values x, y from this array whose sum will be equal to k, and we have to find only two values. Okay, it's not like we have to find a sub array or multiple values with sum to this particular value k. We have to find it's not like that. We have to find only two values x, y, and whose sum will be equal to k. So what we can do, that we can start making pairs. Okay, we will fix a value, and then we will consider the rest of the values which are in front of it as the variable values, and we will start making pairs. So how many pairs we can make from this array? If we are fixing value 1, then we can pair it with 1 comma 2, then with 1 comma 3, then 1 comma 7, and similarly like that. Then we will fix 2, and we will not move backward from here for making pairs. Why? Because we have already made that. So we will move in front. Every time we will move at the front. So we will make 2 comma 3, then 2 comma 7, and then so on. For the last element, we can't make any pair because there is no element after 10. So we have to fix the element only from the 0th to the n minus 2th index. Okay, so clearly it can be seen that um, we have to use nested loops, and the outer loop will be for fixed value, and the inner loop will be for variable value. Okay, so let's write its solution, the brute force one. So as I said earlier, that we need a nested loop where for a fixed value and for variable value. So let's write the loop for I is equal to 0, starting from the 0th index, and where up till where we have to go for the fixed value, last second value, up till last second value. So I less than n minus 1. This is n, this is n minus 1 index, and less than n minus 1 will be this n minus 2, means the second last index. Then I plus plus. And now for the inner loop, what will be the starting index of the variable values when we were fixing this value 1? we were starting from the very next of it. Okay, it means if our fixed value index is I, then the variable value index will start from I plus 1, and up till where we will go? We will go till less than n, or we can say n minus 1th index. Then we simply increment it k plus plus, and then what we need to find? We will be getting the fixed value from ARR of I and variable value from ARR of j. Then we will implement this condition, or we will write this condition if our sum of fixed value ARR of I plus the sum of the variable value, that is ARR of j, is equal to k, then we will simply return true. Otherwise we will close this bracket and we will simply return false at the end. Okay, why I didn't write any condition if our sum was not equal to k? It is because that we will do nothing. We have to iterate over all the elements of our array. Okay, we have to iterate over all the elements of our array, so we can't terminate our loop here if the sum doesn't match. We have to check on the other elements as well. So this is our brute force method which we have written, and let's discuss its time complexity. So the time complexity will be, let's find it. This is a linear loop, so its time complexity is n. This is a linear loop, so its time complexity is n. And since they are nested, so time complexity will be product of the n's. It will be n square. And space complexity, we are not using any extra space, so our space complexity will be order of 1. So this is our brute force method. So can we improve this solution? Can we? So yes, we can improve this solution. We will, as we can see that our space complexity is already best order of 1. So we will focus on this, the time complexity. So let's discuss its optimal approach, which I say the optimal approach for it. I call it as two-pointer approach. Okay, I call it as two-pointer approach. So what is a pointer? Basically, pointer is a variable. Pointer is a variable which is used to indicate something, like it indicates on something. Okay, it can indicate to a memory location, or it can indicate to a particular index or anything. Okay, so what was our array? Our array was 1 2 3 7 9 10 and 11. Okay, let's consider this. Sorry, I have increased one value, but that's not an issue. Our sum was 10. Okay, so what we are going to do here is that, let's write me once again, 1 2 3 7 9 10 and 11. So this was our array. Okay, and its index will start from 0 1 2 3 4 5 and 6. So what we are going to do is that we will be taking two variables to iterate this array. The first variable will be our start variable, which will point at, initially it will point at the 0th index, and the second variable will be our last variable, which will point at the end value of the, or we can say the at the end index of that array. Okay, and we will check, we will see further how we can like solve this problem using these two variables. So let's give you little bit hint or a dry run of my approach, the two pointer approach to solve this problem. Okay, suppose we add these values at index start and value at the index last. Let's add it. ARR of start plus ARR of last. What we get? At the start we have 1, at the end, or we can say last, we have 11. So we will add 1 plus 11, we will get 12. And what is our target? 10. K is equal to 10 is our target. So we can clearly see that the sum is greater than K. Okay, sum is greater than K. So just think that this array is sorted, and if we move the start pointer to one level next of its next, okay, we will move the start pointer to its start plus 1, then it will point to 2. Then the next value of the start, the next value stored at the index of start in the array will be greater than the previous value, or it may be the equal or the same value. Okay, but it's never going to decrease because our array is sorted. Okay, so this sum will not decrease. This will not decrease if we do start plus plus. It will never decrease. It may remain same or it may increase, but it will not decrease. And what we need to find, we have seen that our current sum is greater than K, so we need to reduce this sum to find whether that it is equal, there is any value with whose sum is equal to 10 or not. Okay, so what we can do, we can like decrease the last pointer by one value. Okay, so what it will happen, it will start pointing to, it will point to 10 now. Okay, then we will find the sum 1 plus 10, it will be 11. See, the value decreases. We can see this sum decreased, but it is still greater than K. Then we will perform one more operation, last minus minus. Then it will start pointing to this variable 9. Then we will find the sum 1 plus 9, and we will get 10, and boom, it's equal to K. And we have find the sum. So we will simply break, or we will simply exit the loop, and we will return the value. Okay, so I think you got the little bit idea of this approach, like how it works. So basically, let me repeat once again, there are two pointers, start and last, which we will use to iterate over this array. And then we will find that the sum of the array values which is stored at the starting index and the last index, and we will compare it with the value K. If the value is equal to K, then we will simply return the value, we will simply return the true. Otherwise, there are two conditions, it may be greater than or it may be less than. Okay, if it is greater than K, then we will simply decrease the last pointer by 1. If it is less than K, then we will increase the start pointer by 1. Okay, this is the proof. And up till when we will run the loop, we will run the loop till our start pointer is less than last pointer. Okay, if they are same, what if they are same? If they are same, it means that they are pointing to some same value. Okay, and this is not allowed. Like same, we can't return the same index. We have to return two different indexes, or we can say we have to find two different values stored at two different locations. It may be we have to find some 6, and we can get 3 comma 3, but these three are from different location. It's not like there is only one 3 in the array and we will return like yes, the sum is possible, we can find by adding 3 two times. No, it's not like that. These we can find the sum if 6 if there are 2 3 values. Okay, if there are 2 3s present in the array. Okay, so we will run till our start is less than last. So let's discuss its code. So our code will be like, first we will initialize a start as 0 and last as n minus 1. Then we will run a loop while start is less than last. Then we will check whether our sum of start and last is equal to k. If it is equal to k, then what we need to do? We will simply return true. Okay. What if it's not equal to 2? Then it may be greater or it may be less than 2. So if our, I'm not writing this complete statement, I'm simply referring it as sum. Okay. If this sum is greater than k, then what we need to do? We will simply perform last minus minus. Simply reduce the last pointer to reduce the sum. Else it's simple that it's not equal, it's not greater than, it will be less than k. Then we will increase the start pointer by 1. Okay. And we will end this loop, and at last we will return false. Why we return false? Because if it doesn't find any condition where the sum is exactly equal to k, then it means that it will never execute this statement, and it will not return any value. It will reach the end of the loop. It means that we didn't got any answer, so we will return the false. So what is the time complexity of the solution? Let's discuss that. There is only one loop, and it's moving in linear fashion. Okay, it's moving in linear fashion. So what will be the time complexity? Our time complexity will be order of n, and our space complexity will be order of 1, since we are not using any extra time space, any extra space. Okay, so this is the problem. This is the optimal code for the two sum problem, and I have discussed only one uh, category of this problem where we have to return a boolean value. I'm not going to discuss the second category in this video because it will be too long. We In the next video we will find what if the array is not sorted and we have to return its indexes. This will be a good question. So thank you, uh, thank you everyone for like continuing this video till end. So if you like this video, so please drop a like, and share this video to your friends if they are struggling with this problem, and do subscribe to this channel. Thank you.